Functions and inverses. Question 2. The graph of f of x is equals to 2x squared is drawn below. Study the graph and answer the questions that follow. We see the graph, it's a parabola that has only one intercept. I mean, it intercepts, it cuts the origin at 0 map 0. So we have a given point, but the x coordinate is unknown. The y coordinate is 2. We can see that this given point is on the second quadrant, and on the second quadrant, y is positive and the x is negative. So definitely that x should be a certain number which is going to be negative. Let us now go to the questions. The question says, determine the x coordinate of A. That's the first question. The x coordinate of A. Already we have the y coordinate. So we need to understand that this point exists on this graph, this particular function. It exists on this particular function. This point. So whenever we have the y value, we can get the x value from this function. Or whenever we have the x value, we can get the y value. Determine the x coordinate of A. So for 2.1, f of x is going to be 2x squared as given. F of x is y. When you see f of x, you see y. Y is equals to 2x squared. What is the y coordinate there? It's 2. Substituting the y coordinate, 2 is equals to 2x squared. Of course, we are going to divide by 2 both sides. Of course, we don't have to do that for a grade 12 question. We divide by 2 both sides, which will give you x squared is equal to 1. Putting a square root on both sides there, when you put a square root on both sides, on the right-hand side, you have a plus minus. Therefore, x is plus minus 1, because the square root of 1 is just 1. But remember, this x is either a 1 or a minus 1. But remember, we are on the second quadrant where x is negative in this particular quadrant. Are we together? So that tells us that therefore x is in fact minus 1. That's the x coordinate of A. That's the x coordinate of A. Let us look into the second question. Determine the equation of h of x, where h of x is actually the inverse of f. Let's see. Firstly, remember that is 2.2. Remember that, of course, the function was given as f of x is equal to 2x squared, meaning it's actually y is equals to 2x squared. To get the inverse, whatever was in this equation, whatever was x must become y, whatever was y must become x. So therefore, we are going to have x is equals to 2y squared. Divide both sides by 2. Because we have to make y to be the subject of the formula. Let me rewrite this so that is going to be 1 over 2x. Y squared is equals to 1 over 2x. Are we together? Because you divided by 2 both sides. So y squared is in fact equal to that. Okay. then when we put a square root on both sides, we have such that y is equal to plus minus the square root of 1 over 2x, which is the f inverse. Therefore, since this is f inverse, it is equal to the function of h, because h, the function h, is f inverse. And that is the answer for 2.2. Let's go to 2.3. 2.3, where we are going to use this graph paper, because 2.3 says draw the graph of h. Draw the graph of h on the same Cartesian plane on diagram sheet 1. Clearly show all intercepts with the axis and the symmetry line. Now, what happens then here is, that's the question for 2.3. Now, I want us to look into this, where we have to draw the inverse of this particular function, which is the function of h. This particular function must now be drawn on the same set of axes with that function, with the original function. What you need to understand with this function is that, and let me take you through this. In an inverse function, the domain of the original function is the range of the inverse, and the range of the inverse is actually the domain of the original. And we'll see that in the next question as well. So whatever was x in the original function will be y in the inverse, and vice versa. Now, since this function that we are having, the original function, existed when at a, when x was minus 1, y was 2. And there should have been another point when x was 1, y was 2 on the other side, because this is point A, when x was minus 1, y is 2, and there is exactly another point here when x is equal to 1. That's why x was plus minus 1. Then y is 2. We know that such exists. So if there were such points, those 2 points that exist, it means for this new function, we should have an A, let's call it A image, which whatever was x will be y, and whatever was y will be x. So there now will be a point which is not minus 1 map 2, but will be 2 map minus 1. 2 map minus 1. There will be such a point. And it means there will be another point as well if we had called this point B. It means we'll have a point B image which is 2 map 1. So based on that, we can go on and plot our function. Our function, if that, we need, of course, to use a ruler. The graph paper has disappeared here. But if this was 1 and this point was a 2. It means now, also if this point was a 2, and this point, this one was 1. What it means now we are looking for a point, not 1 map 2, not 1 map 2, but we are looking for a point 2 map 1. 2 map 1. 2 map 1 is a certain point there. Also, we are looking for a certain point. This is -1, which is 2 map -1. Of course, the origin is going to be there because whatever was x becomes y, whatever was y becomes x. So 0 map 0 becomes 0 map 0. Then you will be able to now, from there, to say this point is 2 map -1, and that point is 2 map 1. You are able to draw your hyperbola, or rather your parabola, and this parabola behaves this way. This parabola behaves this way. And this parabola is going to cut, or rather intersect here, and that intersection, you would realize that that point of intersection is actually half map half. The line of symmetry, or rather the axis of symmetry, because this is an inverse function, the line of symmetry is about the line y is equals to x. Meaning, that is why these functions are cutting there. When x is 1 over 2, y is 1 over 2. The symmetry line goes there, exactly there. It goes 0 map 0, it goes at -1 map 1. And the symmetry line must be, in fact, in dotted line. You can't be drawing a symmetry line. You'll use a ruler for this. You can't be drawing a symmetry line using, drawing it as a hard line. And it's going to pass at 1 map 1, it's going to pass at 2 map 2, at 3 map 3, 4 map 4, and so forth. And that becomes your function. And you'll just name your function to say this is your function of h. And you are sorted. You will get your 3 marks based on finding the origin, because it's 3 marks. It's 3 marks. You've been able to find the origin, which is 0 map 0, that the graph starts there, and the intersection point, of course, and the shape of this graph. Remember, this is a graph. This is an inverse graph. It's not an inverse function. This is not a function. This is a function, but this is not a function. Of course, we're not going too much into functions now. We are not dealing with the topic of what is a function and what is not a function. But this is not a function. There will be more videos on what is a function, what makes something a function, and what makes another thing not a function. And now let us look at 2.4. 2.4, we are looking for the domain. That's what they are saying. Write down the domain of h, meaning write down the domain of the inverse function from the original function. Now, how do you write that domain? Let's look at the range of the original function. Because the range of the original function is the domain of this particular function. It's inverse functions. Whatever was the domain becomes the range, whatever was the range becomes the domain. So the range of this function, remember it started at y is greater or equal to 0. So y existed everywhere from 0 up to infinity. It means the domain of the inverse must therefore be x exists from 0 up to infinity, where x, of course, is a real number. Another notation, you don't have to write both of the notations, but another notation could have been x is an element of all numbers from 0 up to infinity. That is the domain of this particular function. The next question is, because it said write down the domain of h, that was 2.4. The next question is 2.5, determine the value or values of x for which, and it's only 2 marks, for which f of x is less than h of x. When it's 2 marks, you need to look from the graph. Let's look into the graph. When do you see f of x being less than, or rather, yes, f of x being less than h of x, it should always be below f of x, h of x. So from here, when x is 1 over 2, look at that, we can shade that. That's where that graph of f is actually, in terms of y values, below the x. The h. So what are the x values when this phenomenon is taking place? When the y values of f are less than the y values of h, it's that region. Why are we saying the y values? Because f is y and h of x, remember, it's y values. So when the y values of f are less or equal to the y values of h, what are the x values? That's the question. When the y values of f, because f is y, isn't it? And h is y, isn't it? When the y values of f are less than or equal to the y values of what? So let's look at the y values. Y values of f, they are below h. So it's that region. What are the x values there? Of course, the x values, you would see that they are between, that's 2.5. The x values then would be between, between 0, because 0 here, and the x value here is 1 over 2. So the x values are between 0 equating and 1 over 2. And that question is now fully answered. All those questions are now fully answered. You get your 10 marks. Okay, keep on keeping on. Goodbye.